Well, good morning, everybody. My name is Mark Lomelli with the Pacific States Marine Fisheries Commission, and thank you for having me today at your conference. Today I'll be talking about research on developing bottom trawl gear that has reduced bottom contact. There are several individuals involved in this project, and they're listed here on the slide. So this research is focusing on the groundfish and bottom trawl fishery. In this fishery, trawls are outfitted with bottom tending doors and lengthy sweeps designed to maintain seafloor contact and herd groundfishes toward the trawl mouth. And while this gear configuration is highly effective at herding groundfishes, its bottom tending characteristics can impact bottom dwelling organisms, including structure forming invertebrates and the physical habitat. Thus, gear modifications that can reduce trawl seafloor interactions while maintaining fish catches would have positive impacts to bottom dwelling organisms, the groundfish resource, and their associated habitats. So here's a bottom trawl schematic. Moving left to right, you have the trawl door, sweeps, bridles, and the net. And the first part of this talk, we'll be focusing on sweeps and making modifications to them to reduce trawl seafloor interactions. So trawl gear modifications and sweeps. Conventional sweeps are known to play a significant role in herding demersal fishes towards the trawl mouth. However, because of their long length, often greater than 275 feet, they constitute the most significant portion of the ground gear that contacts the seafloor along the tow line for any given trawl event. Therefore, sweep modifications could have the greatest effect at reducing trawl seafloor interactions. So the objective of this research, at first we wanted to compare the catch efficiency of demersal groundfishes between conventional and modified sweeps with elevated sections along their length. And second, we wanted to examine how the sweeps interact with the seafloor. And this research was conducted on the fishing vessel Last Straw during 2018 off Oregon. So here's an image of conventional sweeps. This is a 3/4 inch steel cable covered with continuous 3-inch rubber disc packed across their length of 300 feet. And here are our modified elevated sweeps. Here we have 1.9-inch combination wire with 7-inch diameter disc clusters spaced at 27 feet intervals along their overall length of 300 feet. In concept, this design elevates over 95% of the sweep off bottom at a nominal height above the seafloor between the disc clusters of 2.6 inches. And below are some images of sections of the modified sweeps. And here's a schematic, just kind of illustrating the spacing of the disc clusters, 27 feet apart. And between those spacings, the sweeps are about 2.6 inches above the seafloor. So as I mentioned, one of the objectives was to look at the sweep's seafloor interactions. A mechanical trawl sweep altimeter, which incorporated a tilt sensor, was used to measure the sweep height off bottom during this research. And here's the housing on the trawl sweep, which incorporates the tilt sensor. And that was placed in the middle between the two disc clusters to look at the sweep's height off bottom in that location. And further, on the research vessel Pacific Surveyor, we towed a sled outfitted with a Ditson imaging sonar orthogonal to the trawl tracks made by the fishing vessel Last Straw. So in your upper right-hand corner, we have these trawl tracks. This one here would be made with conventional sweeps on the trawl, and this track here would be with the modified sweeps on the trawl. And across 3 sections, we towed that sled with the Ditson to look at the trawl seafloor interactions. So what did we find out? No significant catch efficiency effect of changing from conventional to modified sweeps for groundfishes such as thorny heads, sablefish, lingcod, dover sole, trawler sole, and wreck sole. So they caught equally, that was good. The Ditson imaging sonar showed 95% of the sweep's 300 feet length was off bottom. And the altimeter data showed the mean height off bottom of the modified sweeps between the disc clusters was 2.4 inches. And these results are similar to prior research in Alaska. So it's good to see that transferability of research and results between fisheries. And here's a Ditson imagery of the starboard swept path. This is from the sled being towed across the trawl track there. Here we have the starboard door track mark. And now we're moving into the area of the sweeps. And what you'll see on your screen is about every 4 meters, you'll see a line that starts to appear. And what those lines are, those are the disc clusters, tracks on the seafloor. So in between those tracks, the sweeps are fishing on a mean height of 2.4 inches above the seafloor. So this is allowing infaunal and lower profile epifaunal organisms to pass under the sweeps without disturbance. And below is a website link where you can see further video of the modified sweeps, the foot rope, and the conventional sweeps as well. And here is a mosaic of imaging sonar frame grabs. This is just showing you sections of the sweeps and what it looks like. And these white arrows here, those are the tracks made by the disc clusters. And in between those tracks, the sweeps, as I mentioned, are about 2.4 inches on average off the seafloor. And this research is available in the Journal of Fisheries Research. If you wanted to read more about it, you can access it there. Or you can contact myself or one of the co-authors and we can provide a copy for you. So the next step moving forward. Semi-pelagic trawling for groundfishes. This is an upcoming research project we have for 2021. You may ask, what is semi-pelagic trawling? This is using midwater trawl doors and elevated trawl sweeps on a demersal trawl. By design, this gear configuration would eliminate over 85% of the trawl's footprint from the seafloor. Our upcoming study will compare semi-pelagic trawl gear to conventional bottom trawl gear for harvesting demersal groundfishes off the West Coast. And this is a collaborative project between the Pacific States Marine Fisheries Commission, Oregon State University Simmers, Oregon Department of Fish and Wildlife, the Northwest Fisheries Science Center, and Groundfish Fishers. So here's a side view of conventional trawl gear. We have our bottom tending door, our sweeps, and our bridles. And here's a side view of semi-pelagic trawl gear. We have our midwater trawl doors here and our elevated sweeps incorporated into the design. In this area in red, this is the area of reduced trawl seafloor interactions with this design. And here's a top view of the two trawl designs. And this just illustrates the differences of trawl seafloor contact. For the conventional gear, we have the doors, the sweeps, and the bridles. And for the semi-pelagic trawl gear, we have seafloor contact occurring at the disc clusters on the elevated sweeps and the foot rope. So really a big difference in interactions. And here's just a short video animation illustrating semi-pelagic trawl technology. And so here, the bottom tending doors have been removed, and they're now replaced with high aspect ratio midwater trawl doors on a demersal trawl. So this just kind of illustrates this technology. Okay. So the objectives. We want to conduct a catch comparison analysis between semi-pelagic and conventional trawl gear for groundfishes. We want to quantify the degree to which semi-pelagic trawling reduces seafloor contact. And we want to compare door spread and fuel efficiency between the two trawls. Our expected results, we're expected to demonstrate that semi-pelagic trawling can be effectively used, as in other fisheries, to harvest groundfishes. We look to find significant reduction in trawl seafloor interactions with the semi-pelagic trawl gear. And we expect to find wider door spread and reduced fuel consumption in the semi-pelagic trawl design. So I'd just like to make some acknowledgments. I'd like to thank the National Marine Fisheries Service Bycatch Reduction Engineering Program for providing funding and support, the Northwest Fisheries Science Center for facility use and collaborative project support, and our project co-authors, collaborators, and at-sea volunteers. So with that, I'd like to say thank you. Thank you again for having me at this conference. And if you have any questions, I'd be more than happy to answer them during the question sections that's coming up. So, great, thank you.